Well, let's go ahead and take a look at taking the derivative of logarithmic functions. We'll take a look at both logs with a base of a and then more specifically with our natural log with the base of e. So when we start out with this log function with a base of a, we don't know how to take the derivative of it. But just like for many of these logarithm functions we've been dealing with, there are all sorts of types of functions. The trick lies in simply rewriting it into a form that we do know how to take the derivative of. So if we were to exponentiate both sides of this equation, or take both sides as the exponents to some power, we should be able to rewrite this as a to the y is equal to x. Right? And those are two equivalent equations. If we can get the derivative of one, should be just as good as the other. And the benefit of writing it in this way is we know how to take the derivative of a to the y. We'll just need our exponential rule that we had from before and a little bit of implicit differentiation. So taking the derivative of the left side, a to the y, derivative of a to the y is a to the y. And since y is just kind of some stuff, we also need to multiply that by the derivative of that stuff. And also because it was a to the y, we also need to multiply that by the ln of a. And all of that, when you take the derivative of x, is just 1. All right, and we need to rearrange this a little bit. We talked about how if our starting function is in terms of x, it makes sense for our derivative to be in terms of x, and we should solve for that dy dx by itself. So we can first isolate the dy dx by dividing both sides by a to the y and the ln of a. And then in order to help us actually write this in terms of x, we need to get rid of that y in the exponent. And looking at this a to the y equals x that we started with, we should be able to kind of swap that out for this a to the y and our derivative to get us dy dx is equal to 1 over x times the natural log of a. And that right there is kind of our general rule for taking the derivative of a log with base a. To do the same thing over here with our natural log, we could either just use this rule or kind of go through the same process. Either way, we should get the same result. Let's go through the process again just to get the hang of it. ln of x is basically just log with a base of e. So if we were to rewrite that, we'd have e to the y is equal to x. Take the derivative of both sides, so the derivative of e to the y, or kind of e to the stuff, is just e to the stuff times the derivative of that stuff. And the derivative of x with respect to x is just 1. Once again, we want to solve for the dy dx. So divide both sides by e to the y. And since we don't want our derivative in terms of y, but rather in terms of x, we make a nice quick substitution, swap out the e to the y for what we know it's equal to, x. All right. Those are our last two derivative rules of the unit. Let's just look at a couple examples that use them and we should be good. So first example. We've got y is equal to the quantity x squared plus 1, taking the natural log of that. We'll go ahead and practice our natural log derivative rule. Taking the derivative, we'll have dy dx. So this is going to be a chain rule here. If the derivative of the ln of x is 1 over x, we can think of this as kind of the ln of stuff. So the derivative of that stuff will be 1 over that stuff times the derivative of the stuff, yielding 2x over x squared plus 1 for our derivative. Okay. Next example. Here we've got a choice. We could simply just go ahead, kind of do it the same way we did the last one, or if we can recognize that we've got some logarithmic rules that we could use, it might help us rewrite this. So choice 1, let's just go ahead and do it the same way we've been doing it. The derivative is going to be 1 over the stuff times the derivative of the stuff. Now the derivative here of the stuff is going to need a product rule. So that's going to be first times the derivative of the second plus the second times the derivative of the first is just 1. And we could factor out that e to the x, leaving us with x plus 1, and in the denominator we'll have x times e to the x. We could reduce out the factor of e to the x, leaving us with dy dx is equal to x plus 1 over x. The other way to go about this is if we were to rewrite using one of our log rules that says that if we're taking the log of two products, we could split that up into the sum of the logarithm of each product. Now this makes it a little bit easier to think about because we don't need nearly as much chain rule. And in fact, if we were to just take the derivative as is, the derivative of ln of x is 1 over x. The derivative of the ln of e to the x, well, that still requires a little bit of chain rule. 1 over the stuff times the derivative of the stuff. And we'll see we're going to end up with just 1 over x plus e to the x over e to the x, which is just 1. 1 plus 1 over x plus 1. These two are equivalent. If we were to just get a common denominator, the two derivatives we came up with are equivalent. So we can see either one is fine. One requires a lot more chain rule, product rule, and factoring, whereas if we knew our logarithmic properties, it made it a little bit easier. Let's take a look at just one more. All right, same idea. We could go two ways with this. We could either stick with the way it is, or we could rewrite. Sticking with it the way it is, we'd have dy dx is equal to 1 over the stuff times the derivative of the stuff would be x times dy dx plus y times 1, so we don't need that. And now we're going to have a lot of factoring on our hands here. Why don't we see how this looks if we were to rewrite? We'd have y is equal to the ln of x plus the ln of y. If we take the derivative of this, we get dy dx is equal to 1 over x plus 1 over y dy dx. We still need to rearrange some terms to isolate this, but it's going to be a lot easier. Let's subtract that 1 over y dy dx from both sides. Now we can factor that dy dx out. Divide both sides by that factor. And just clear out the fraction and the fraction there, multiply everything by y. Numerator and denominator by y. And it should give us y over y minus 1 times x. Probably a little bit easier than if we went the other way. But we should get the same answer.